Hello. For those of you who actually attended the live version of this slide presentation, you'll know that this is not that version. That version turned out to be rather more eventful than I would have liked to have actually put up onto YouTube. So I'm going to re-record the lecture. It'll be the same material, but without the interruptions that we had during the lecture. For those who weren't able to make it at the actual lecture, then it won't make any difference whatsoever. I will, however, be splicing onto the end of this video the questions that were asked at the end of the lecture, so that they can be available to everybody. So let's start then with this current presentation. This is the first lecture in the Foundations of Syntax course, and in this lecture we'll be addressing a rather basic issue, and that is essentially what is syntax. In particular, we're going to be looking at the syntax of natural language, and natural language is basically what I'm using now, the kind of language that humans use for various purposes. Now we can contrast natural language with other kinds of things which might be called languages. For example, formal languages, the languages of mathematics, for example. Also with other communication systems used by other animals. Now in doing this comparison and contrast between these kinds of different languages, we might be able to learn something more about the nature of natural language syntax. Okay, so let's start then by having a look at a rather simple syntactic system, and that is the system, the syntactic system used by arithmetic. Most expressions in arithmetic follow this same basic pattern. You start off with a number, then you have a sign, followed by another number, followed by the equal sign, followed by another number. For example, here are some easily recognizable expressions, arithmetic expressions, and they all follow this basic pattern. Now, we can contrast these examples with the following one, which is, from a mathematical point of view, clearly wrong, because 20 plus 23 isn't 42. However, you can see that this follows the same pattern as the others. So although the others are mathematically correct and this one isn't, they all are the same in as much as they follow the same pattern. We might say, therefore, that this expression, even though it's semantically wrong in terms of its meaning, it's grammatically correct. This is a grammatical expression, and it's a grammatical expression because it basically follows the rules. We can see, therefore, this pattern we've got in one on this slide here as being a rule that tells you how to form grammatical expressions within the arithmetic language. Perhaps that can be made even clearer if we contrast this with another example. Now this example here seems to be well, fairly much gobbledygook. It's not entirely clear what it's actually saying. It could mean 2 plus 2 equals 4, in which case it would be mathematically correct, but it's entirely unclear that that's exactly what it's trying to say. Alternatively, it might be 2 plus 4 equals 2, which would be incorrect. But the point is, the reason why it's not clear what this means is because it doesn't follow the same pattern. It doesn't follow the rules of the grammar, and therefore we might say that this is an ill-formed or an ungrammatical expression within this language. Now, that star at the beginning of this expression is what we use to indicate ungrammaticality. Ungrammatical sentences or expressions are things which don't follow the rules, the syntax. of the language. So from this then, we can learn that syntax is a set of rules which tells us how to put things together to form grammatical expressions. From that, the important aspects are rules and putting things together to form grammatical expressions. Okay, so coming back to our rule of arithmetic, we can see then that this is actually able to produce something more complicated than the examples we've seen so far. For example, this expression is also defined as grammatical by this rule. Now the way this works is because what the rule itself says is it's actually a definition of what a number is. A number is a number followed by a sign followed by another number. That's the definition of a number according to this rule. And of course what we have here is two instances of such things. So for example, 2 is a number, plus is a sign, and 3 is a number. And according to the rule, anything that is a number followed by a sign followed by a number is a number. Therefore, if that object there, in brackets 2 plus 3, is a number, it can go into the same position as another number in the actual rule itself. It can go in that first position. Therefore, it can be followed by a sign and followed by another number, and of course 8 minus 6 in brackets is also another number by the very same argument as we've just put forward, and therefore that equals another number. In other words, what we've got here is that the same rule is able to apply multiple times within a single expression. Now when that happens, we say that we've got something called recursion going on. The same rule being recursively applied to the same expression to define something more complicated than just a single application of that rule. Now it turns out that natural languages have recursion too. So this is one way in which natural languages and this formal language, one thing that they have in common. However, there are rather large differences between natural languages and formal languages, and the best way to see those is to compare the two. So if we move on to have a look at a comparison between them. The first thing to say about the way these two languages differ is that with arithmetic syntax, the rules are actually very simple. And that's understandable if we consider the fact that the language of arithmetics is actually very limited in terms of what it actually needs to convey. Essentially, the only thing you talk about with arithmetic is quantities, or the quantities that those quantities are made up of. And that's all you need to talk about. That's the only thing the language needs to express. Natural languages, on the other hand, are far more complicated than that. They are virtually unlimited in what they can express. They can express virtually anything that you can think of. And for that reason, the syntax itself needs to be of a level of sophistication to be able to express minute changes in nuances and the sorts of things that we might want to actually use the language to express. So therefore, it's going to be obvious that the syntax of arithmetic is going to be very simple, whereas natural languages is going to be far more complex. Following on from that, there's also a difference between the two languages, which again leads us to understand why the grammars are as they are, and that is that in maths, in arithmetic, the syntax is actually relatively unimportant. The main thing we want to use the language for is to express the quantities. It's the meaning of the expressions that are the most important thing, and the only role that the syntax plays is to make those meanings obvious. As we've seen, expressions which don't follow the rules, it's totally unclear what they are actually trying to say. So the syntax helps us to express the meanings in a clear and unambiguous way, and therefore it doesn't really matter what the syntax is like as long as it fulfills that function. In comparison with natural languages, however, we can see that actually the syntactic system is very central to natural languages. In terms of what languages can express, they're all pretty much of a muchness. They can say more or less the same things in different languages. You can translate something from one language to another, and therefore, in terms of their expressive power, they're pretty much the same. This is not so, however, of their syntactic systems, and it's on their syntax that we can see that different languages are actually defined. So it's the syntax which plays an essential part of defining what natural languages are. So in that case, we can see a rather big difference between formal language syntax and natural language syntax. Let's move on now to have a look at animal communication systems and compare those to natural languages. Now, the majority of animal communication systems tend to involve particular calls or songs or noises which have a single meaning. For example, animals might want to communicate that there's danger about, or that their present location for other members of the species to know where they are. However, in this sense, what we seem to have is expressions which consist of just one element. Okay, there's one sound related to one meaning, and therefore there's no combination of elements. And as we've seen, syntax is about how you combine elements to form grammatical expressions. And as there's no combination of elements in these sorts of communication systems, simply put, there's no syntax to them. So this is obviously not very comparable to what goes on in natural languages. This isn't to say, however, that no animal communication system has the kind of feature whereby elements get combined, and therefore they all don't have its syntactic systems. Some of them do. We'll take a look at a couple of them here. The first one is to do with bees and the way bees communicate to each other the location of flowers, which obviously is an important piece of information for a bee. Basically what happens is that a bee who has found a source of nectar will fly back to the hive, and if you think about it, hives are organised vertically, standing up. So they fly to the hive and they basically do a dance, a certain type of movement, and by observing this movement the other bees will learn where to find the source of nectar. Basically this dance is a D shape, and like a D it has a straight part and then a curved part. It's the straight part of the dance which conveys meaning. For example, a bee might dance directly upwards in respect to the orientation of the hive, the vertical nature of the hive. So it might dance upwards and then come round and back round again. And this dance continues going straight up and round. Now what that means is for the other bees to find the flowers, what they have to do is when they leave the hive, they have to fly straight towards the sun. So the vertical straight up part of the dance indicates you've got to fly directly towards the sun. On the other hand, if the dance goes downwards with respect to the position of the hive, the orientation of the hive, that means that when you leave the hive you have to fly in the opposite direction, directly away from the sun to find the flowers. And obviously then the bee can dance in any particular direction within the hive to indicate any particular angle with respect to the sun that you have to fly. So for example, if it danced crosswise to the right, that would mean to say that when you leave the hive you have to fly at a 45-degree angle from the position of the sun. Okay, so by this dance then, the angle of the dance indicates the direction that you have to fly. So the dance contains information about direction. But that's not the only thing you can convey with the dance. Bees, when they do this straight part of the D dance, they also can wiggle a bit. Now, this also has implications for what the dance means. A small wiggle means that the flowers are close by to the hive. A big wiggle means that the flowers are more distant from the hive. So this wiggle part can convey information about the distance of the flowers. So the dance in itself then combines these two pieces of information in one dance. The direction of the flowers and the distance of the flowers combined into one expression or one dance. Another example of an animal communication system that involves the combination of elements to form complex expressions is from a group of monkeys called Campbell's monkeys. Now, like other monkeys, Campbell's monkeys have sounds, calls, which have a single meaning, so one call, one meaning. For example, the sound crack, whatever that sounds like coming out of a Campbell's monkey's mouth. I'm not entirely sure what it sounds like, but let's suppose it sounds something like crack. That means leopard. It's a danger call, alerting the other members of the troop that there's a leopard about. Okay, so that's a one sound, one meaning kind of expression. But the difference between Campbell's monkeys and other monkeys is that they can combine these one sound type things into others to form more complex expressions. So for example, if you add the sound oo to crack, then you get another expression which means a general disturbance, not a leopard, but some general disturbance in the vicinity. Furthermore, you can add another instance of crack to this, and you get crack, crackoo. And that then means that there's a leopard nearby. So you can see here that what's going on is that we are taking elements and we're adding elements to form expressions which differ from each other. Okay, they have distinct meanings and therefore are different expressions. This is another way in which you can find combinations of elements within animal communication systems. Okay, so how does that compare then to natural languages? Well, the first thing to point out is that the two systems that we've looked at so far, the bee dance and the Campbell's monkeys calls, they are very different from each other. For a start off, a bee dance is something which contains two pieces of information which are simultaneously presented in a single dance. It's like saying this distance, this direction. Those two pieces of information are combined into one. So this is simultaneous expression of different meanings in one form. That's not actually what's going on with Campbell's monkeys. With Campbell's monkeys, the combinations actually result in a completely different meaning. So you have an element with one meaning, you combine it with something else, and you get a meaning which is different from the original one. It's not like an addition of this meaning plus this meaning. Now, we can see, if we compare that to what goes on in natural languages, that natural languages are more similar to the Campbell's monkeys type system. So, for example, take a sentence, a simple sentence of English, John loves Mary. Okay, this sentence has a meaning that is more than the combination of the meanings of the words. It doesn't mean John and love and Mary. Okay, that would be the bee dance way of looking at meaning, where you combine the two separate pieces of information into one additive meaning. Okay, this sentence means John loves Mary, which goes beyond the meaning of John and the meaning of love and the meaning of Mary. You get a different meaning than the meaning of the elements. Specifically, it means that John is the one doing the loving and Mary is the one getting it. And that itself is a meaning carried by the sentence, clearly beyond the meaning of each individual word or a combination of those words. Therefore, we can see that in natural languages, the meaning of the expressions, the sentences, are different in nature from the meaning of the individual elements of the words. And that is similar to the Campbell monkeys type system rather than the bee dances. However, there are huge differences between the natural language and the Campbell's monkeys communication system too. It's not just a matter of there being a different meaning. With natural languages, it's clear that the meaning of the sentence has got something to do with the meanings of the words. You can understand the meaning of the sentence John loves Mary if and only if you understand the meaning of John, the meaning of love, and the meaning of Mary. They contribute to the overall meaning of the sentence, and although the sentence meaning is different from the individual word meanings, you can construct the meaning of the sentence by knowing the meaning of the words. In other words, the meaning is entirely predictable as long as you know the rules. Campbell's monkeys, on the other hand, the relationship between the meaning of the component parts of these complex expressions and the meaning of the expression itself is not entirely straightforward. It's not clear how you get from a meaning of leopard to a meaning of a general disturbance by adding "oo" to the meaning to the word meaning leopard. And then it's not clear how you get from the meaning of general disturbance plus the meaning of leopard to an expression which means there's a leopard nearby. It seems, moreover, that what we're getting here is that the complex expressions are given a meaning which has very little to do with the meanings of the words that it contains or the elements that it contains. And in that sense, the complex expressions are more like words themselves. They're given a meaning for that particular combination of elements rather than finding what the meaning is by putting somehow the meaning of the words together. So the meanings of the Campbell's monkeys complex expressions is pretty much unpredictable, okay, and behaves more like a word. Furthermore, we can see that with natural language syntax, the syntax actually is one of the things that contributes to the meaning of the sentence. You can take a sentence with exactly the same words, but put them together in a different order, and you'll get a sentence that means something else. So John loves Mary and Mary loves John, completely different sentences that don't mean the same thing. One of those sentences doesn't even entail the other. That is, just because John loves Mary doesn't mean to say that Mary loves John. So one of the sentences could be true and the other one could be false. So you can see then that it's it's not just the meanings of the words that contribute to the meaning of the sentence, but it's also something to do with the way the words are put together. And that, of course, is syntax. Syntax is about how you put things together to form complex expressions. So the syntax actually plays a role in determining the meaning of the sentence. And again, that seems to be very different from the kinds of language communication systems of animals that we've looked at so far. Okay, so to conclude this presentation then, we can round up what we've just said about what natural language syntax is. First of all, it's a complex system of rules. Okay, it's not entirely simple, like a mathematical language. It's complex, but it is a system of rules. And that system of rules tells us how to combine elements, words, into something more complicated, an expression, a sentence in natural languages, but in such a way that produces a grammatical sentence. By following the rules, you produce something which is grammatical. Those sentences have an unlimited expressive power and can say anything that you can think of. Therefore, the rules have to be able to cope with this fact about language. And the meanings of these sentences come from the meanings of the words that they contain, plus some aspect to do with how those elements are combined. Okay, in other words, the syntax tells us part of what the meaning of a complex sentence is. Okay, so that's the presentation done. I will now put on the part of the live lecture which dealt with the questions at the end of it, and I will hopefully see you next week. Thank you. Bye-bye. If there are any questions now, I can take questions. If not, then we can close the meeting. So if anybody has got any question about what we've seen today, let me know.
Yeah. Oh, it's for the exam. Sorry, what can we know about the exam?
Well, we're a bit early to talk about exams at the moment. I will actually have a session towards the end when we're coming to the exam, where I'll go through some example kind of questions to sort of to prepare you for the exam, or at least what to expect. But essentially the exam is going to be multiple choice type questions. I think I will set it up on Canvas as a one of those kind of multiple choice quiz type things. Now if we were having the exam in an exam hall, there would be 50 questions, an A, B, C, D kind of multiple choice thing, and that would be how it is. For this exam, I don't know. I'm going to have to look into it in terms of how many questions I'm going to put. Because in order to try to make this fair and straightforward, I'm going to try to use the Canvas capability, whereby you can put in various types of various examples of questions or various versions of questions, and then different people will get different questions. That's going to avoid any kind of accusations of sharing and cheating if everybody is doing different exam papers. So I'm going to be looking at that. But if I'm going to do 50 questions per 50 questions per exam, and there are 3 exams, and then I've got to do versions of those 50 questions, that's going to be an awful lot of questions I'm going to come up with. So I'll have to see how many actual questions there will be, but obviously towards the end of the exam. will there be any homework? Somebody's asking, and the answer is no. No, this is a lecture, so there's nothing nothing to be done in terms of classwork or anything like that. That's a more seminar thing rather than a lecture. The only requirement is that you attend the lectures, and you can do that either live on Zoom or by getting the recording. Okay, is there a book? There is a book. It's called Basic English Syntax. It's by a group of people, including myself, from the university. It's available in a number of copies from the library, but you can download it. Okay, it's available on the internet, various download sites. So if you type in or search for Basic English Syntax with exercises, you can find a PDF version of it and download that. So you don't have to go and buy anything or go to the library, if the library is even open. I'm not entirely sure whether that's true. Okay.
I have chapters to read from the Basic English Syntax.
Okay, yes. Okay, if you already have the book, then actually the book is more useful for later lectures, not necessarily the foundations. The first chapter, really, of that book is going to be what we're going to sort of cover in these lectures, and some of the initial lectures, like the one today, isn't really going to be covered in any book. Okay, they're a little too basic, I think. But once we start getting into more details about syntax, then the first chapter of that book is going to be fairly useful. There are other introductory books for linguistics. I don't know if they're available online or anything, but essentially any introduction to linguistics, the chapter on syntax is going to cover more or less the sort of stuff that you need to know. We're going to be dealing with some pretty basic issues like word categories, nouns, verbs, etc., etc., grammatical functions like subjects and objects, phrase structure, which is to do with how we put sentences together to form larger units than words but smaller units than sentences, etc., etc. So anything that deals with word categories, grammatical functions, phrase structure, those things are worth reading. There isn't a specific textbook for this lecture. The exam is going to be based on the lectures themselves. Okay, so really, if you've seen the lectures, then you should have enough information to be able to sit the exam.
With the presentation that you showed us in this lecture, will be available on the campus?
Yes, what I've done is recorded it. Unfortunately, I've recorded it with all the interruptions and everything like that, but there's not much I can do about that. I've recorded it, and then what I'll do is I'll make it available. I'm going to post it up onto YouTube, which is a good format because it's easily accessible, and you can kind of rewind it and move it back if there was some point or something that you missed or you want to hear again. You can easily sort of like go backwards and forwards in it. What that's going to need, however, is once I've finished this, I need to edit the file to get it to be uploaded to YouTube, and then once it's uploaded to YouTube, I've got to make it available. What I will do is put the link to the YouTube video on the Canvas thing for this course. So if you go into Canvas,
can you upload just the the presentation to the canvas?
That won't be entirely useful to you because of the animations. The animations are going to be, if you open the thing up, what you'll see is a sort of like a rather confusing page. Okay, I'm not entirely sure that that's the most useful thing for you. The presentation is going to be up on the video, so that's recorded. So you should be able to sort of see that on the video, and that I think is as much as you need, really.
Okay, thank you. Thank you.
There was a question in the chat. How many times World Cup sense endured? And I'd like to ask as well because I might be only able to watch the recorded lectures.
Okay. As is the case with all things at Delta, lectures don't have an attendance requirement. You don't have to attend the lecture. Obviously, you need the information that the lecture contains in order to take the exam. So that's why I'm recording it, basically, because there are some people who just can't attend at this time. So I'm recording it to give the best of both worlds. You can attend the live lecture and at least have this kind of opportunity to ask questions and have some sort of like personal contact, or you don't have to be here. You can watch it whenever you like once it's uploaded, and that way you can still get the information. It's entirely up to you, and it's dependent on your own circumstances. I would suggest if you can make it to the live performance, then fine, do that. But if you can't, no big deal. Just watch the recordings. Okay. Hopefully that caters for everybody. All right.
Thank you.
Okay, now we're coming up. We've only got about 3 more minutes left before Zoom kicks us off, and unless there's anything else, then I think we will close here. I'll see those of you who can make it next week, and hopefully it won't be quite as eventful a lecture as it was this week. I think I'm going to have to disable my doorbell or something like that. Okay. In that case, I will say bye-bye now, and I will see you all next week. I will, as soon as I can. It won't be today because I'm teaching virtually all day today, but as soon as I can, I'll edit this video and get it posted up and put the link onto Canvas so you can get it sometime tomorrow, I'm hoping. Okay, see you all next week then. Bye-bye.